Second day of math traps. Very exciting. Three more traps after the three from Tuesday. So let's look at ratios of ratios of ratios. So here's the trap. Ratios don't always refer to the same numbers. Best way to do this is get a common denominator and make sure everything lines up. And you'll see what I mean here in a second. The trick here is to make sure that the numerator and denominator kind of refer to the same item. So here's an example. Ratio of W to Y is 4 to 9. So as you can see, I wrote 4 for W, 9 for Y. And then the ratio of Y to Z is 6 to 5. A little tricky here. You'll notice the order switches. If I'm going to then compare the ratio of W to Z, I want W and Z to be in the same location. So notice they are both in my numerator. That means that Y is both of my denominators. So let's get them to be equal denominators. So because we're going to kind of compare these fractions and we want to see how W compares to Y and Z compares to Y with the same Y's. If I can do that, I can answer this question. So looking for a common denominator, looks like it's going to be 18. So that means I multiplied 9 by 2, which gives me 8 for W. And then 5 would be multiplied by 3, since 6 to 18 is 3, so 15 for Z. So that would be 8 to 15, answer A. The next trap is checking only positive integers, and we've seen a couple problems like this already. Let's talk about them a little more thoroughly. So the trap here is that we get really excited when we're doing these problems, and we only test one scenario, and that is usually positive numbers. That's not enough as long as we're reading the stipulations, which is kind of the trick here. There might be extra stipulations that kind of change what I'm testing, but if it doesn't give you a very narrowed down look at the numbers, that means you're going to have to try a bunch of different stuff. So don't just try one thing, try a bunch of things. And the numbers that are passed up more often is negatives and fractions. So let's take a look at a question that deals with that. So x is any value. So notice it says any value, not integer, not whole number. Any value but not 0. Which of the following are true? So if I want to try the first one, it's pretty tempting to like plug in, say 2 plus 2 greater than 2 minus 3. I already figured out that that one is false. That's no good. So I tried a positive, it didn't work. Great. I plug in a positive number here for squared, 2 squared greater than 0. That is true. And it's really easy to go, okay, well that one worked. Let's just double check real quick and see if it works for negative. So if I had negative 2 squared, is that greater than 0? Yes, because that's 4. You're squaring a negative, you plug in with parentheses around whatever you're plugging in, that gets squared. That means it's positive 4, which is greater than 0. Excellent. So that worked for me as well. Let's check out like a fraction. So like a half squared, is that greater than 0? Yeah, 1/4. And you can do this in your head. You don't have to write it down. But that one also works. So I tested a positive, a negative, and a fraction. They all worked. I'm not testing 0 because it told me not to. 0 would not work in this case. So it looks like at least 2 is true. That knocks out A for me. That knocks out C, since C says only 3 is true. It could be B, D, or E. Well, I guess not D at this point because 1 did not work for me. So B or E at this point. Let's plug in for the last one. So I plug in 2. I get 8 is greater than 2. Excellent. I'm thinking true. So very tempted at this point to put E. However, let's try a negative. Negative 2 cubed greater than negative 2. That is negative 8 since it's cubed. That's negative 2 times negative 2 times negative, which is negative 8 greater than negative 2. That is false. So it turns out not to work. It was very tempting because I only tested a positive at first to say that it was definitely true. So B is my answer. Only 2 is true. Fractions would also fail for that last one, by the way. And the last idea is counting is hard. Pretty easy for us to lose track of things. Let's say I want to know what are the numbers between 1 and 4 inclusive, meaning include 1 and 4. You would say, how many are there? There are 4. 1, 2, 3, 4. That's pretty easy. But when we get in a hurry and we subtract to try and answer something like that, so for example, 10 to 20 inclusive, how many numbers are there? It's very easy to say 10. We take 20 minus 10 and we get 10. However, that's wrong. There are actually 11. Don't believe me, you could count it out. I'm not going to do that here now, but there are actually 11. So here's the idea. If you are subtracting the bottom and top of a range to try and find out how many objects there are, if they're numbered, between those two numbers, you need to add 1 to the number you get. And the trick here is not to hurry. It's pretty easy to lose track of what you're doing. So let's say we're at Trefzger's. I'm excited. We pull a ticket with a number on it when you come in the store so that they can serve you better. If the first number pulled in the day is 12 and the last is 254, how many customers did they have that day? The trap here is to subtract the two and you go, okay, well that's 242. Yay, I'm right, but you're wrong. You didn't include 12. You don't really count that first number when you subtract two numbers. It's actually that plus 1, which is 243. So be careful when you are looking at a range of numbers. You need to make sure that you include the first one that's counted. So do add 1 when you subtract.